Hi, we're taking up the nth term formula of the AP, which is given by, it will be an a plus n minus 1 d. This is the formula given to find the nth term of an AP, wherein you know by the time is a stands for the first term, n is for the number of terms we are calculating, and d is the common difference. Let us take a few examples or a few questions to make ourselves clear about the usage of this or the application of this formula. First is, suppose I take up, there is a series which says 3, 5, 7, 9, so on. It says find the 50th term of this AP. How do we find? We have learned the formula. It says an, that means we'll be calculating a50. So that's given by a, that's the first term is 3, plus the formula needs n minus 1, so our n is 50. D is the common difference, so in our series d is written as 5 minus 3, that is 2. So our d here is 2. We'll use that d here in the formula, so I get 50 minus 149 into 2 gives you 98, so that is 101. So the 50th term of the given AP is 101. That is the first basic application of the nth term formula. We take up another example to see how differently the nth formula can be used. First says show that the progression to the series is in so that the series is in AP, and also find its nth term. So what are the number series? The number series is given by 7, 2, minus 3, minus 8, and so on. That's very simple. If we want to prove any series of numbers to be in AP, we have to see if the difference or the common difference between the numbers remaining same. So a2 minus a1 is given by 2 minus 7, that is minus 5. a3 is minus 3, minus 2 is again minus 5. And then it is minus 8 minus of minus 3, that is minus 8 plus 3, that is also minus 5. So we easily prove that this series is in AP. This series is in AP. Fine. Now our next thing is to find the nth formula or the nth term of the series. We learned a little while ago how it is a plus n minus 1 d. Your a being the first term is 7. We don't know n, we have to find that out. D we found to be minus 5. Now it becomes 7 minus 5n plus 5, that gives you 12 minus 5n. So the nth formula or the nth term of the AP is given by the formula 12 minus 5n. We move further to make ourselves acquainted with this formula and maybe the various applications. I take up another example or another question here. Let me just write it down. It says which term of an AP is given by 5, 13, 21 is 181. That means we have to find the n for which the term is 181 in the given series. So an is already given as 181. Here your first term being 5, so a is 5, and d is the common difference, it is 13 minus 5, that is given by 8. Let us apply the formula. It is a plus n minus 1 d. This is given by 181. So let us quickly solve this equation. I'll let n to be this side. 5 minus 8 is minus 3. When I carry to the right, it becomes 181 plus 3. So 8n is equal to 184. N is equal to 184 by 8, that is 23. So the 23rd of this AP, 23rd term of this AP is 181. Very simple. I hope you are going well with the formula. A couple of more questions. Now this is another example and a different type of application of the same formula. Which term of AP, which is given as 3, 10, 17, so on, will be 84 more than its 13th term? Doesn't sound complicated. Just a minute, it will take very easy solution. Here let us understand what it wants. It wants us to find the n, or the number of terms at which it is 84 more than its 13th term. So to know that, we have to first find out the 13th term of this AP. We find out A13. We again apply the formula a plus n minus 1 d to find it out. A being your first term, that is 3, plus n is given to be 13 minus 1, it's 12, and d can be calculated as 10 minus 3, that is 7. As because it is already given that this number is an AP, we don't have to check about the common difference. If it is an AP, only A2 minus A1, that's giving you D, will be taken up as D. No need to check for the rest of the terms. Now what is 12 into 7 is 84. 84 plus 3 gives you 87. So the 13th term of this AP is 87. Now the question wants us to find the term. Now which term is 84 more than the 13th term, which is found to be 87? So they want us to find the nth term, or the n for the term 171. So again we apply the formula to find n here. Here the first step we found the 13th term. Now we need to find which term is a 171. So we again use the same formula. A plus n minus 1 d is now given to be 171. A remains same with 3, n is supposed to be calculated, and d was 7 before. This is given to be 171. Let us just wait to make a little bit of movement to make myself some space. Fine, that's enough. This will be 3 plus 7n minus 7, that's 171. 3 minus 7 is minus 4. If I carry that to the other side, it becomes 7n equals to 171 plus 4, that is 175. So n is 175 by 7, that I think is given by 25. So the 25th term, fifth term of the given AP is 84 more than its 13th term. I hope you are now getting more confident about taking up questions on nth term. We quickly take up last one. It says find the value of P. Find P, or the value of P, for the three consecutive terms of this AP given as 2P minus 1, 7 and 3P. It says these are all in AP. We just have to find the P value. If they are in AP, that means A2 minus A1, A3 minus A2 will be equal. The D will be equal. So A2 is 7 minus 2P minus 1, that is 7 minus 2P plus 1, that's given by 8 plus 2P. For A3 minus A2, it is 3P minus 7. These are the common difference of the AP given, so they should be equal. So let us form an equation which says 8 plus 2P is equal to 3P minus P. Let us take up the P, or move the P's to one side. That makes it minus P is equal to minus 15. Oh, did I make any mistake somewhere? Oh yeah, I made some mistake. Let me correct myself. Here, if you see, it should have been a minus 2P. So I'll just have to change myself with a bit of correction here. So this will be a minus. So 8 plus 7 is equal to 5P. If I carry P to the other side, this gives me 15 equals 5P. So P is 3. So the value of P, which we were supposed to calculate in this question, stands for 3. And in that case, this series is in AP. Thank you.